Imagine looking at a giant star one day and finding it completely gone the next. Deep within the fireworks galaxy, NGC 6946, mysteries unfold in the silence of the void. Throughout the universe, massive stars follow a predictable path. They fuse lighter elements until they forge iron at their core. This iron core is the star's final fatal achievement. When gravity finally overcomes the star's outward pressure, we expect a violent, spectacular explosion. This supernova should scatter heavy elements across the cosmos, leaving behind a luminous remnant like the Crab Nebula. Astronomers have spent decades waiting for these cosmic fireworks. Yet, when observing massive stars, they often find that the expected blast never occurs. The star simply vanishes, leaving no brilliant light in its wake. In the life of a massive star, the ending should be cinematic. When the core runs out of fuel, gravity pulls the layers inward, triggering a catastrophic rebound, a supernova. But for some stars, that light never comes. There is no blast, no radiant shockwave, no vibrant remnant left behind. The star simply vanishes into silence. We call this the mystery of the failed supernova, a process where gravity wins the ultimate tug of war, leaving us with nothing but a void. Astronomers have a reliable method for counting massive stars in our universe, the Hertzsprung-Russell diagram. By observing luminosity and temperature, we can accurately predict how many stars should reach the supergiant phase. Yet, here lies the problem. Based on stellar birth rates, our models predict a steady stream of supernova explosions. But actual observations show significantly fewer events than expected. This leads to a haunting question. If these massive stars exist, why aren't they exploding as predicted? Where are the rest of them? The disappearance of N6946-BH1, from our view, was not an end to its story. While the visible light from the star vanished, astronomers detected a faint, lingering infrared smudge in the 2015 data. This infrared echo is crucial evidence. It tells us that the matter wasn't simply blown apart by an explosion. Instead, it was still being pulled and consumed into a singularity, glowing faintly in the infrared spectrum as it disappeared. It is a quiet, final feast, a signature of a massive star collapsing directly into a black hole. The leading scientific theory for these failed supernovae is direct black hole formation. In massive stars, the core can become so dense that the internal pressure, which normally resists collapse, is completely overwhelmed by the star's own gravity. Instead of the outward explosion typical of a supernova, the star experiences a silent, catastrophic implosion. It collapses inward directly into a singularity, bypassing the bright death throes we are accustomed to observing. Recent data suggests that the disappearance of these massive stars is not a rare anomaly. Instead, it is a statistical reality. Evidence points to a staggering conclusion. Up to 30% of massive stars may end their lives silently without the brilliant explosion of a supernova. This reveals a universe that is far quieter than our previous models predicted, changing our understanding of how galaxies evolve. A massive star is a delicate balancing act. Like a lighthouse, it shines through a constant tug of war. Nuclear fusion pushes outward, resisting the crushing weight of gravity. For millions of years, they remain in perfect equilibrium. But eventually, the fuel runs out. The outward pressure fades, and gravity becomes the ultimate winner. When the light goes out, the structure doesn't just dim, it implodes. Gravity pulls every layer inward, transforming a giant star into a singularity. Our investigation of N6946-BH1 has revealed critical clues. This 25 solar mass star vanished from our visible sight, leaving behind only a faint, lingering infrared glow. We now conclude that this silent death is not an anomaly. It is a valid scientific classification, fundamentally changing our understanding of how massive stars end their lives. We once viewed the cosmos as a place of constant fire and fury, but we now understand it holds silent, unseen voids where giants once stood. A universe of secrets hidden in the silence of the void. What do you think happened to this missing star? Did it vanish into a black hole, or is there another cosmic force at play? What do you think happened to this missing star? Tell us your theories in the comments below. Subscribe for more deep space mysteries.